Hi everyone. In this lesson, we will talk about measurement scales. We can classify the variables by how they are categorized, counted, and measured. To do this, to be able to classify the data, we categorized, counted, or measured variables using measurement scales. The four common types of the measurement scales are nominal, ordinal, interval, and the ratio scales. The first type is the nominal scale data. It is categorical data in which no order or ranking can be imposed, such as names, colors, gender like female, male, eye color, blue, green, hazel, brown, study field, maths, engineering, medicine, and nationality. Second type is ordinal scale data. Classified data into categories that can be ranked, but precise differences between the ranks do not exist. What I mean, the order matters, but differences cannot be measured. For example, letter grades like A, B, C, D, F, rating scales, poor, good, excellent, or judging first place, second place, third place. The third one is interval scale data. Data ranks, the order matters, and the precise differences between units of measure do exist. So you can measure the differences, however, there is no meaningful zero. For example, temperatures and IQs. And the last one is ratio scale data. It is same as interval scale data, but here there exists a true zero. So order matters, differences are measurable, and contains a zero starting point. For example, height, weight, time, salary, age. As you know, height or weight cannot be less than zero. So let's analyze them one by one. Let's go back to nominal scale data. For example, we can assign 1 to female and 2 can be male. The order we place it doesn't matter. Female doesn't have higher value than male. They are arbitrary, they're random. Male could be number 1 and the female could be 2. It doesn't change anything. Or we can assign red color to 1 and 2 to blue color, 3 could represent green, and 4 could represent black. As I said, the order doesn't matter. Blue could be 4, red could be 2, and like green could be 1. This form of data cannot be used in calculation, but responses can be used in calculation. So what I mean, let's say we ask 10 people about their favorite color. Imagine that we ask 10 people about their favorite color. And let's say 3 of them chooses the red and 2 of them chooses blue, 1 chooses green, and the 4 chooses black. So out of a total of 10, I can say by using this information, 30% choose red, 20% choose green, 10% blue, 10% choose green, and the 40% choose black. As you see, I cannot use red, this part, blue, green, or black in the calculation as their categorical data, but I can use responses, which 3 of them out of 10 say red, 2 out of 10 say blue, or 4 out of 10 say black. I can use those responses in calculation, but I cannot use this information, first set of data, in any calculation. So let's talk about the second one, ordinal scale data. This type of data used to rank things. Let's look at the letter grade. Let's talk about the letter grades. A, B, C, D, and F. Here, the order matters. However, differences cannot be measured. For example, the difference between the grade A and B is not same as the difference between B and C or D and F. So let's say one student gets 95% of the grades and they get a grade A, and one student gets 80% and gets grade B, and another student gets 60% and gets grade C. The differences between A and B is 15 marks, but the difference between B and C, it's 20. Here is 15, here is 20. So differences, it's not same. So let's give another example to make it clearer. Imagine there is a running race, and let's say first, there is a first place, second place, and the third place. In that race, let's assume the first place runner finished the race in 4 minutes and 20 seconds. And the next one, the second one, finished 4 minutes and 25 seconds. And the third one finished at 5 minutes and 30 seconds. The differences between first and the second places is very little. It's just, if you look, it's just 5 seconds. But the differences between second and third places is more than a minute. If you look at the differences between second and the third, is more than a minute. So by using the first part of the data, by using this part of the data differences cannot be measured unless you give this part of the data. So let's do one more example. Let's give one more example. Let's say we're ranking the staff performance, and let's say the options are the first one is excellent, second one is good, and the third one is, let's say, bad. So, and let's give excellent the value 1, the good the value 2, and the bad the value 3. Here, excellent has the highest value and bad has the lowest value. But we cannot really measure the difference between the excellent and good, or good to bad. We just know excellent is better than good and the good is better than bad, but measure the difference is not really possible. So this is again an ordinal scale data. Now, let's move on to interval scale data. For this one, order does matter, and the differences can be measured. Temperature is a good example. So for interval scale data. So let's say we have 10 degrees Fahrenheit, 20 degrees Fahrenheit, and 30 degrees Fahrenheit. The differences between 10 and 20 is 10. So between the first and the second temperature, it's 10. And between second and the third, it's 10 again. So the differences can be measured. However, we cannot measure the ratio. What I mean with that, for example, if you divide the second the temperature 20 by the first 10, you will find 2. But this does not mean that it's twice as hot. Next thing here is there is no true zero. For example, 0 degrees Fahrenheit is not the lowest temperature, because you could have negative temperature. It could be -10, it could be -20, -30. So here the order is matter, as 10 degrees is less than 20 degrees and the 20 degrees is less than 30 degrees. You can put them in ascending or descending order, but it's matter, the order is matter. So let's talk about the next one, the ratio scale data. For this one, order is matter as well. Differences can be measured, including ratios, and it does contain 0 as starting point. So let's give an example about grades. Again, let's give an example, not the letter grades, the normal grades. Imagine that we have the grade 80, 50, 75, 90, and 30. So order is matter. We can write them in ascending order. So 30 is the lowest grade, then 50, 75, 80, and 90. So order has meaning here. 30, we can say, is the lowest grade, and the 90 is the highest grade. And I can measure the differences, for example, between the lowest and the next lowest grade. The differences is 20 marks, or from the second to third, it's 25 marks. We can see the differences are measurable, and we can also measure the ratios. For example, I can divide 90, the highest grade, by the lowest grade, which is 30, and find 3, and I can say this student got 3 times higher than this student. So it makes sense now. And the last thing, it does contain 0 starting point. Let's say we have another student who didn't answer any question, or didn't answer any question correctly and got 0. So we have a 0 grade here, which will be at the beginning, yeah? And this 0 has meaning. That means student didn't answer any question, or didn't answer any question correctly. And also, student cannot get any score lower than 0. So this is ratio scale data. Let's summarize what we have learned today. We talk about nominal, ordinal, interval, and the ratio scales data. So first one was nominal scale data. This one doesn't have meaningful order. So we can say doesn't have meaningful order. And next one was ordinal scale data. Ordinal scale data does have meaningful order, does have meaningful order, but difference, it's not measurable. And the next one is interval scale data. Interval scale data. This one has meaningful order. So does have meaningful order. And difference is measurable. Difference is measurable. But there is no meaningful 0. No meaningful 0. And the last one was ratio scale data. This data has meaningful order. Meaningful order. Difference can be measurable. Difference can be measurable. And there is a meaningful 0.